Today we worked in groups to visualize data using R. We formed our groups within our tables, and the first thing we did was to introduce ourselves to one another and decide who at the table had the least experience using R and ggplot. We defined that person to be the coder. I would recommend that anyone else following along online and working in a group do the same thing. It's great to have the person who has the least experience actually sitting and typing the commands, because this way we can make sure that everybody at the table is on board with the things that are happening. In this video, I'm not going to do that. I'm going to just fly through some commands so you get a high-level overview of what happened in class today. So the first thing I'm going to do is I'm going to create a new R script. This R script is going to hold all the commands that I type. Then I'm going to go over here in the website and see that the first step is to prepare the environment. So I'll copy this line of code, and when I run that line of code, it loads the tidyverse. Remember, the tidyverse is an R package, and it contains a suite of functions that we'll be using repeatedly throughout the course. The next thing I'll do is to load the data. So I'm going to copy this line here and paste it into my R script. What this line does is it goes to this URL on the course website and gets a comma-separated values file from that URL. The function readCSV reads that data file and then stores it in a new object called data. You'll see over here that in my global environment, I have that data object. We can type data down here in the console and have a look at what these data look like. These are the data from the table in the Jenks paper. Each row represents a country. For each country, we have several summary indicators of well-being in that country. The first indicator is the 90-10 income ratio. To make this indicator, they took the 90th percentile of household incomes and divided that by the 10th percentile of household incomes. You could interpret the ratio column as saying that in Sweden, the high-income families get $2.6 per year for every dollar that the low-income families get. The higher the ratio number is, the greater inequality in that country. The next column is GDP. This is gross domestic product per capita, and it's presented as a fraction of US GDP for comparison's sake. So we could think that a country with high GDP is one where there's high well-being overall. The next column is life expectancy, and you can read about that in the Jenks paper. We won't be visualizing it today. So let's visualize these data in a plot. As you scroll down the course website, you can get code for a basic ggplot. I'm going to run this code and then walk through what's happening line by line. So I've got my cursor up here in my R script editor, and I'm going to hit Command Enter to run the code. Down here in this pane, you can see the plot that results. On the x-axis, we have the ratio variable. On the y-axis, the GDP variable. This plot's going to tell us something about how inequality on the x-axis is related to productivity, GDP per capita, on the y-axis. This point in the top right is the United States. Its GDP is at 100% of US GDP, and there's very high inequality in the US. The other points represent other countries. Okay, so how did we make that plot? I started with the data object. I then used the pipe operator to pass that data object down to a call to ggplot. This operator basically says to take the thing that comes before it and use it as the first argument in the next function. So then I have this call to ggplot. This particular line looks really complicated, but it's a line you'll be using again and again throughout the course, so it's worth getting familiar with how it works. In a call to ggplot, you use the function ggplot. Everything in R with parentheses is a function. That function here has one really important argument. That's the mapping argument. The mapping argument tells R which variables in the data should go onto which parts of the graph. So here we see that the ratio column is placed on the x-axis, and the GDP column is placed on the y-axis. When we run just this part of the code here, we get kind of a blank canvas of a plot. To finish the plot, we added a layer. Within ggplot, you connect layers with this plus sign at the end of the code. We added the layer geom_point, and what that did is it added points to our plot. There are tons of layers you could possibly use in your ggplots. So to illustrate just one more, we could have a layer with geom_label. Geom_label is like geom_point, except instead of points, it's going to put labels on the plot. In order to do that, it needs to know what text should go on each of these points. Remember that each point represents a country, so here we might add a new mapping argument where we tell it that label is going to be the country column. And when we do that, we've now plotted labels on top of our points. You can go on in this exercise and do lots of things, like add axis labels and make the plot super easy to understand. You can see an example down at the bottom, where I've created one particular ggplot that I liked myself. At the end of this exercise, we took a step back and talked in our groups about how we would interpret this graph. What does this tell us about inequality and how it relates to GDP, and how the US compares to the other countries in the plot?